Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the chain rule. So, when you have to use the chain rule and what are the process you have to follow. Now, before we are seeing a function is given, a function, if the function is given like this, we will use directly the fx. So, f of x comma y, which is given by x square plus y square plus 2x. So we will calculate directly. This is the partial derivative, which is equals 2x plus 2 with respect to x, fy, which is 2y. Now here there is a function of function which is given. So first, to write it this one, we have to understand the rule first. What is here? The x is a function of x and y is a function of x and y is a function of t. So I will draw a diagram here. This is y is a function of x and x is a function of t. So all are one variable, therefore we will use the d. We will use the ordinary differentiation dy over dt. So how will you calculate dy over dt? Dy over dt, it is dy over dt. What is the in-between variable you have? The in-between variable is x. So I will write it here d and d. Why we are using d? Because it is a single variable. If it is a two variable, we will use here do, right? So this is the formula. It is very easy to understand from here. So y is a function of x is a function of t. I want to calculate the dy over dt. It can be calculated. I write it dy as dt as it is. And what is the in-between variable? I write it that one in place here, x dx. Is it right? So this is the formula. No need to remember the formula, this one. So directly you can construct the formula by your own. Now I will solve this one here. See, this is the same idea. Y is a function of x, y is a function of x, and x is a function of t. X is a function of t. I want to calculate dy over dt. What is the answer? Dy over dt. So the formula I am writing here, dy, this is dt here. What is the in-between variable? In-between variable, which is what? X. So I write it here dx, I write it here dx. If you cancel, you will get dy over dx. So therefore, after that, it is the same thing. What will calculate this one? So differentiate this one with respect to x. So what is the differentiation? It is 2x plus 2. The 5 becomes 0. And what about the t? X with respect to dt. So I am taking this one and differentiate with respect to t. You will get 2. You will get 2. So after getting this value, if you multiply, you will get what? 4x plus 4. So here you have to substitute the value of x. What is the x value? X value is equal to t. I just substitute 2t here. So you will get 8t plus 4. So this is the final answer because dy over dt, everything must be in terms of t. That's why we are substituting the value of x. Now if you see this one, it is the function of t. Function of t. So this is the answer. Now let us go with the second case. What happened in the second case? Here, z is a function of xy. Z is a function of xy and and x and y is a function of t. Is a function of t. So I have to calculate dou z over dz because it is a single variable. Is it right? So if you do it this one, it is with respect to dz over dt, single variable. dz over dt. How will you calculate? This is a very important. Listen here. When you have to use the partial, when you have to use the ordinary derivative, here you have to know. So here z is a function of two variable. It is partial derivative. Here you have to use the partial derivative. If you come to the next one, next level, x and y is a function of one variable. We have to use the ordinary derivative d. Ordinary differentiation d. So let us go with this one. I write it dou z over dou x plus dou z over dou y. So this is the derivative with the x and y is done. Now coming to the next one, how will you calculate this part? In between variables x with respect to dt, dx over dt, dx over dt. Sorry, dy. So this is dy over dt, dy over dt. So see the difference between this one. If you have a problem with this one, or you can remember the formula like this. I write it dz dt. So here dou z hina dt plus dou z over dt. So I write it the value dou x dx, dou y dy. So if you understand like this, you will never forget the rule. So two variable partial, one variable ordinary. That's why you will have a d here. That's why you will have a dx over dt, dy over dt, because it's a single variable. X is a function of t, y is a function of t. But z is a function of x and y. That's why it is a partial derivative you are using. Now it is the same thing here. The question it is given. If the z, if z is a function of x and y, and xy is a function of t. So this is the same case you have xy, and then xy is a function of t. So same rule, I have to calculate dz over dt, dz over dt. How will you calculate dz over dt? So this is dou z over dou x plus dou z over dou y. This part is done. This part is done. Now coming to this one. So now coming to this one. So what is this? Dx over dt, dy over dt. That's it. So thereafter you can calculate all the values. So what is here? The first one, this part, differentiate with respect to x. So you will get 2xy plus x become 1, you will get 3y power 4. This is done. Now what about dx over dt? Differentiate with respect to t. So you will get cosine 2t into 2. Cosine 2t into 2. Then this is the first part is done. This is about the first term. Now the next term we have. What is the next term? Plus. What are the next term here? We will have the value which is differentiate z with respect to y. So y become 1, you will get x square plus 12x y power 3. So this is the first term. Now what about the next term here? This y with respect to t. So it is minus sine t. Minus sine t. Now the question is asking here to find the value of at a point. What is the point it is given? 0. So I will calculate dz over dt at a point t equals 0. When I substitute t equals 0, sine t, the entire term becomes 0. Sine t 0, the whole thing becomes 0. Now coming to this one here, we will calculate the t equals 0. So here, what is x equals 0? When t equals 0, what is the x value? What is the x value? Sine 0, 0. And what is the y value? So sine 0 is 1. So I will just substitute in the first. So you will get here, this is 2 times of this also here, the x value is 0. The entire term is 0. 0 plus 3 into 2 cosine into 1. So you will get the answer is equal 6. So this is how you will find it the value of x. The value at the point. Next one. Here we will have the same thing. The function. So what happened here? This is t. So first of all, we solve this one. This is the same model. This is the same model here. So what happened? This is the same model. So write it the function first. So if you write it the function, you will never forget about this one. So z is a function of x and y. Z is a function of x and y. X and y is a function of t. So I will calculate the same thing. So if you want to calculate the dz over dt, so we have to formula use the rule. So dz over dt, so dou z over dou x and plus dou z over dou y. Now this is done. This part is completed. Now I will go with the next level. What is the next level? Differentiation with respect to ordinary, because one variable, dx over dt, dy over dt. So after that, calculate the remaining things. So what is this? With respect to x, it is cosine x, cosine y is a constant as it is. And then what about the next step? X with respect to t. So if you differentiate with respect to t, it becomes 1 over 2 root t. Root t differentiation 1 over 2 root t plus dou z over dou y. What is dou z over dou y? So differentiate with respect to y. So sine x is a constant. Sine x is a constant. When you differentiate, sine x is constant. When you differentiate cosine, it becomes minus sine y. Minus sine y. Now what about the next part? Differentiate with respect to y. So it is minus 1 over t square. Minus 1 over t square. Now if you substitute the final answer, that will be this one. So multiplication, only multiplication. So dz over dt equal, it is 1 over 2 root t cosine t cosine x cosine y minus of minus, it become plus, then 1 over t square sine x then sine y. So this is the value for this one. Now here we will have a third case. What is the third case gives? So x is a function of, z is a function of xy, and xy is a function of t. So xy is a function of t. So you have to use here partial derivative. When you differentiate this with respect to s and t, how will you form the equation? See here, very important. So I write it this, dou z over dou x. Why we are using dou not d? Because it's a two variable, x and t. That's why partial derivative. So how will you calculate dou z over dou x, dou s plus dou z over dou s? I write it. What is in between variable? In between variable you have what? xy. So here dou x, dou x. Here dou y, dou y. That's it. Similarly, if you want to calculate that, this is for x. Similarly, if you want to calculate with respect to t, so dou z over dou t, I write it the formula like this, dou z over dou t plus dou z over dou t. So how many in between variable you have? Two. What are they? X and y. So just substitute that one here. Dou x, here dou y. Sorry, this is dou x, and here dou y, dou y. Then only it get cancelled. You will get dou z over dou t. So we will solve the problem using this rule. So all about this rule, using this rule. So let us go with this part here. So z is a function of xy, and xy is a function of s and t. So how will you calculate the derivative? Dou z over dou s, which is dou z over dou s plus dou z over dou s. What is in between variable? You have, which is dou x, dou y, dou y. If it is z is there, you can include the z as well. The how many variables you have, you can add it the terms. Now thereafter it is very easy. What is this one here? You can calculate z with respect to x. So what is x? e power x is e power x, sine y is a constant. We are differentiating with respect to x. So this is done. Now I will calculate the same thing here, plus what is with respect to y, e power x cosine y. Now the next part, it is this one. Differentiate x with respect to s. So x with respect to s. So it is t square. Now similarly, y with respect to s, it is 2st. 2st. That's it. So if you simplify, what is the common part? I will take it e power x is a common. Dou z over dou s is equal e power x is a common. So it is t square sine y plus 2st cosine y. Cosine y. And at the last step, you have to replace the value of x and t. So you have to replace the value of x and t. So how will you replace? What is the x value? This is the value. You have to write it all the variable in terms of x and s and t, not xy, right? So here you have to replace y as this one. This is xt. So replace it. So what happened here? And also the x value. What is the x value here? What is the x value? We have here st square. So I will replace everything xy in terms of this. So e power st square. This is t square as it is. Sine of s square t plus 2st cosine of s square t. That's it. This is the final answer. Now I will take the next one, the with respect to t. So this is the first part is done. This is done. Now I have to differentiate with respect to what? T. So same rule. Dou z over dou t is equal dou z dou t dou z dou t. And in between variable dou x dou y dou y. So calculate this one separately, this one separately. What happened first? It's the same thing. You will find it dou z over dou x is the same. E power x sine y, and here also this part e power x cosine y. Now the next part is what? With respect to t. So when you differentiate with respect to t, it is 2st. Here when you differentiate with respect to t, it is s square. S square. Now here also the same thing, you have to replace the x and y after taking common. We will simplify this part and then we will take the common factor. So what is the common? E power x is a common. You will get 2st sine y plus s square cosine y. We are taking e power x is a common. Now replace. What is replace? X and y. Replace x, here y, here y. You have to replace the value. So what is the value here? E to the power x value is what? St square. St square. 2st is the same. Sine y. What is y? S square t. S square t plus s square cosine s square t. So this is the final answer. It is dou z over dou t. At the last, you have to replace x and y by s and t. That's it. So we will solve one more problem using the same rule, the chain rule. So here you have what? The function. So z is a function of x and y. So I write it that diagram first, x and y. X and y is a function of s and t. S and t. So here we have to use the partial derivative. So it is the same rule. Dou z over dou s is equal dou z over dou s plus dou z over dou s. So in between variable we have dou x, in between variable which is x and y. So I write it here dou x, dou x, dou y, dou y. Only two variable. If it is three variable, we can add it one more term. So calculate the same thing. What is this here? X with respect to x, it is 1 over 3x chain rule. Len is over. When you differentiate inside, it becomes 3 into 3. So here this is done. Now what about this part? I will calculate this one. Dou z over dou t, dou y. So 1 over 3x plus 2y. Len is over. This is len is over. What is inside? What is inside? It is with respect to y, it is 2. This is done. Now I will calculate this one. What is this one? X with respect to s. When you differentiate with x with respect to x become 1, you will get only sine t. Similarly, here, y with respect to s, it is minus t sine t. T is a constant, sine s, sine s. Cosine s become sine s. So what is the answer here? You can just write it. This value here, simplify. So you will get dou z over dou s is given by 3 sine t minus 2t cosine, 2t sine, 2t sine s whole divided by 3x plus 2y, because the denominator is a common term. So this is the answer. But you have to replace the x and y. So in the numerator there is no x term, but in the denominator you have a x and y. So you have to replace that one as the s and t. So here sine t minus 2 t sine s is a constant, is the same. Now here plus 2 plus 3 plus 2. What is the x and y? The x value, which is s sine t. S sine t. What is the y value? T cosine s. That's it. So this is the final answer in place or in terms of s and t. Now this is done. Now I have to calculate with respect to t. So what is the respect to t? Is the same thing. Dou z over dou t equal dou z over, I write it, dou t plus dou z over dou t. And here dou x, dou x, dou y, dou y. Now then I just substitute the value 1 over 3x plus 2y into 3. And this one is the same thing. I calculate. So chain rule 1 over 3x to y into, with respect to y, into 2. This is done. Now what about the next part? So differentiate this one with respect to t, x with respect to t. When you differentiate s with respect to t, it is s is a constant. Sine differentiation become cosine. And similarly, dou y over dou t. So it is what? With respect to t, t become 1, you will get what? Cosine s. Now I will write it this one as a simplified step. So denominator is going to be the same. 3x plus 2y. What about the numerator? 3s cosine t. Here plus 2 cosine s. 2 cosine x. Now there is one more last step. I have to replace x and y by this one. So what is this here? Dou z. Final answer. It will be dou z over dou t is given by 3s cosine t plus 2 cosine s is the same, whole divided by 3. What is s? It is s sine t plus 2 times of, what is y? T cosine s. T cosine s. That's it. Now the next one is the implicit differentiation. And this is a very important question here you have. So first of all, what is the implicit differentiation? As we know from the calculus one, how will you go with the regular method? Regular calculus one differentiation. How will you do? This is, I bring it everything here. So what is the differentiation with respect to x? So 3x square plus 3y square y prime. When you differentiate x, y, it is y prime dy over dx, because y is a function of x. And here is the product rule. So it is 6 is a constant. So x differentiate, y fixed. X fixed, y differentiate. This is right? Product rule. Now I have to bring it the y on one side. 3x square plus 3y square y prime is equal 6y. I multiply inside. So what happened? Plus 6x y prime. So move the y here. So move the y prime on one side and this is term here. So what you'll get, y prime is a constant. So 3y square. This is done. If you move here, change of sign, minus 6x equal 6y will be the same. If you move this one that side, it become minus 3x square. Now if you divide it, you will get the final answer will be y prime equal 6y minus 3x square over this one you have to divide. Is it right? This one it should be over. So this is 3y square minus 6x. This is what you are calculating in the calculus 1. So in the calculus 1, we are calculating this partial derivative in the implicit differentiation in the regular method. But there is a shortcut method. How? So by using this rule, if a function is given, I have to bring everything in the left side and make it the function equals 0. And then I will write it minus fx. How will you remember this function? Dy over dx. How will you calculate? Because f is a function of x and y. X and y. So how will you calculate this one? So this is dy over dx. This one in the numerator minus fx. This one in the denominator. This is simple, right? So I will use the same formula in this way. So what happened? Let us check. So I write it here. This is a function. What is the function? X power 3 plus y power 3. Move it here. Minus 6y equals 0, right? As per this rule. Now this is f. This is f. This is equal f. Now I write it this one. Fx. What is fx? 3x square minus 6y. What is fy? Partial derivative with respect to y. The first term 0. Second term it is 3y square minus 6x. Now just substitute in the rule. What is dy over dx? Y prime, which is minus fx over fy. What is fx? Minus of 3x square minus 6y over, this is what? 3y square minus 6x. If you multiply this minus inside, you will get the same answer. So what is this here? I will write it the first, minus of minus plus 6y, positive term first, the negative term next. Minus 3x square is the same over the denominator going to be the same. It is 3y square minus 6x. Are you finding the same answer? If you see this one, it is the same answer. It is the same answer. Because in the calculus 1, we don't know the partial derivative. That's why we are using the regular method. But here, you can use this rule. For all the problem, use this partial derivative. You will get the easy answer within 2 steps. No need this simplification. Now, let us go with this one. How will you solve? So, I will take more problems. Cosine xy minus 1 minus sine xy minus sine y, minus sine y equal 0. So equal 0. So what is the fx? So in order to calculate the dy over dx, so I have to write it minus fx over fy. So this is the function f. So calculate the fx. What is fx? So this is fx is equal, for the derivative, minus, differentiate with respect to x. I will calculate fx. Differentiate with respect to x. It is our first chain rule. Minus sine xy. This is done. Now when you differentiate inside with respect to x, x become 1, you will get y. Here there is no y term 0. Here there is no y term 0. This is done. The upper part. Now what about the over? Whole over. What about the inside? This one. Fy. Differentiate with respect to y. First here minus sine xy, chain rule. Cosine differentiation minus sine. When you differentiate inside with respect to y, y become 1, you will get x. This part becomes 0, constant. Here minus 0 minus, what is the differentiation of sine? It becomes cosine y. So whereas in the partial derivative, no y prime concept, right? So you have to write it only the derivative. Now multiply, you will get what? Minus into minus plus y sine xy over here. If you multiply, you will get what? Minus sine. So it becomes minus sine xy into x minus cosine y. So this is a very simple answer. You will get it using the formula. So I will write it one more problem. So y cosine x minus x square minus y square. In order to calculate this one, the formula is given by minus fx over fy. This is my f. This is my f. So how will you identify the function, the some implicit function? If it is given like this, it is implicit function. Now if it is given like this one, see, f equal x square plus y square. This is not implicit, this is explicit. So directly you can do it by fx, fy. But here there is no f equal. It is given in the implicit function, implicit form. So you have to bring it everything in the left side and make it as a function. So what it is here? Minus fy. So when you differentiate x, y is a constant, minus sine x. This is done. Minus 2x. Finish. Over with respect to y become 1. Cosine x. This is 0 minus 2y. When you multiply this minus and this minus, it become plus. So you will get 2x plus y sine x over cosine x minus 2y. Cosine x minus 2y. So this is the final answer. Now the next one is the same thing, but here you have a three variable. What is the difference between the last problem and this problem? If you see this f, what is the f? F is a function of what? X and y. Only two variable. So this one is only for the two variable. Two variable. Two variable. Whereas here you will have what? Three variable. It's very easy. The formula you have to remember. Formula is very simple to remember this one. Three variable. F is a function of three variable. So I write it fy, that is fx. What is this? Fx means minus fx over fz. Minus fy over fz. Is it right? So this is very easy formula you can remember. So I will solve an example from this one. So this is the f. Everything in the left side, I will take this as a function f. Now I want to calculate dou z over dou x. Dou z over dou x. So what happened here? It is minus fx over fz. So it is an implicit differentiation, not f is given. So therefore it is implicit form. Now differentiate with respect to x. Minus is outside. 3x square. This is 0 and z is 0 plus 6x 6y is that x become 1. The 4 become 0. Is that right? 4 become 0 over what about the z with respect to z? This is 0, this is 0, this one 3z square plus z become 1, you will get 6xy. 4 becomes 0. So if you write it this one, or you can simplify, this is a final answer. Or you can simplify the 3 common and then you will get the answer will be, the simplified answer will be x square plus 2y. I am taking 3 as a common factor and cancel in the numerator and denominator. So it is z square plus 2xy. 2xy. That's it. This is the first one. Done. Now what about the second one? Dou z over dou y. The formula is very simple. Minus fy over fz. Fz. So same thing. In the denominator going to be the same because it is fz, fz is the same. So only you have to calculate the new thing, it is fy. So what is fy? Differentiate with respect to y. This is 0. Here the second term 3y square. Z term 0. The next one, this is 1. You will get 6xz. 6xz. Similarly, I am taking the 3 is a common factor and cancel. You will get minus y square plus 2xz over z square plus 2xy. 2xy. This is the final answer. So using this, you can find it the values. Now we will solve the last problem of this video here. The function is given z. I have to bring everything in the right side. The f is equal, or we can say z is equal. F is equal e power z minus xyz. Now dou z over dou x, which is given by minus fx over fz. What is fx? Differentiate with respect to x, 0. There is no x term. Minus x become 1, you will get yz over here with respect to z. So e power z is what? E power z minus z become 1, you will get xy. So final answer multiply minus, you will get yz over e power z minus xy. This is the first term. Now second one, dou z over dou y. Formula is simple, fy over fz. So here with respect to y, therefore there is no y term, 0. Minus y become 1, you will get xy. Divided by e power z minus z become 1 xy. When you multiply the minus inside, it becomes xy, xz over e power z minus xy. So with this topic is complete. You can find it the PDF file of this lecture in the description box. Subscribe to the channel. Thank you.